Hello everyone, welcome to Mindspan Education. This will be our last video of the review of mathematics for machine learning. In last video we started reviewing few of the concept of probability and we looked at the multivariate Gaussian random variable, and we saw that for a distribution we have the parameters, and by changing the parameter we can change the shape of the distribution, right? For this case, for case of the multivariate Gaussian random variable, these parameters are sigma and the mean vector, and this sigma is a matrix that is nothing but the covariance matrix, and this mean vector, right? So these two are the parameter in case of the distribution that is multivariate Gaussian, right? And we have seen that by changing these parameters, that is covariance matrix and the mean vector, how the distribution shapes changes, right? Similarly, if you look at the few known or important distributions like Bernoulli, binomial, geometric, Poisson, uniform, Gaussian and exponential, so you see in the bracket, so these are the parameters of the distribution. Like in case of the uniform distribution, A and B are the parameters. What are A and B? So this is your PDF of uniform distribution. So A is the point and B is here this point. So these two extreme points are the parameters of this uniform distribution, because depending upon A and B and depending upon the difference between them, the shape of the distribution will get decided, right? If A and B are too far from each other, then the shape of distribution will look like this, right? So these are the two, A and B are the two parameters that defines this uniform distribution. Similarly, in case of the Gaussian, you have the mean and the variance, right? By changing the mean you can shift the distribution, and by changing the variance you can spread out the distribution or you can narrow the distribution, right? So similarly, we have for the exponential this lambda that defines this exponential distribution, right? And why we are talking about all these parameters? Because by changing the parameter you can change the distribution, so that is why they are important to us. So we just looked at what is multivariate Gaussian random variable, right? And I would request you that if you have already not gone through my probability and statistics course, then you should go through, right? Or otherwise you should have a good understanding of the probability and statistics, then you will not face much difficulties further in this machine learning course. Alright, now let me talk about few things regarding, or few concepts regarding the statistics. Before we go to this a few concept of the statistics, let me talk about that how these probability, statistics and machine learning are connected to each other. Let me take an example. So you have seen that the bank decided to give the credit card not to every user, not to every customer that have the bank account in that bank, right? So based on their profile they decided to give that person should get the credit card or not, right? So let's suppose that the bank have your profile, let me call it as the person profile. What kind of record they are going to have, and that is going to contribute to decide that if that person should get the credit card or not? The very first important aspect is that the person's salary, right? And the type of job that person is doing, and the other important aspects would be like what is his savings and how much he is spending, what is his age, right? So on, right? So this is what the person's profile is. Here, let me first of all introduce few things. So if you look at this, you can look this as a vector having the D features. Let me say that in the person profile we have the D features of the person, right? So the new terminology first of all that I am saying is the feature. And how many features do we have for this person profile? D features. And what are the features? These are the features. The salary is the feature, what kind of job he does, what's the saving, what's the spending, what's the age of that person, and so on. We have such D features, right? And let's assume also that all these features are the real number, right? Then you might have question that how this type of job could be a real number. So you just can think of that like label 1 job or the group A job, group B job, B job, C, group D job, right? And depending upon that you can just assign the 1, 2, 3, 4, right? So let's assume that all these are the real number. So can I say that this is nothing but a vector X or the profile of the first person, right? So the profile of the persons can be represented as a column vector, right, that belongs to d-dimensional space, right? अगर उस बैंक में n number of customers है, n numbers of accounts है, persons के n numbers of accounts, right? So how many such vectors we will have, or the person's profile, that will be x1, x2 till xn. So can I say that all these xi belongs to this d-dimensional space, right? And the very important point is that so this data, all these data is not fixed, right? Person's salary, age, spending, all these will vary, right? So we can think of these features vector as random sample from some underlying process, right? And इसी को स्टैटिस्टिक्स टर्म में हम लोग बोलते हैं कि द डाटा इज सैम्पल्ड फ्रॉम सम अंडरलाइंग डिस्ट्रीब्यूशन. और ये जो आपका डिस्ट्रीब्यूशन है, जिस डिस्ट्रीब्यूशन से हम सैम्पल कर रहे हैं, दैट डिस्ट्रीब्यूशन पैरामीटर आर अननोन टू अस, राइट? और अगर लेट सपोज करो कि आपके पास n नंबर ऑफ अकाउंट्स डिटेल्स है, मतलब कि आपने n सैम्पल लिया है थ्रू दिस अंडरलाइंग प्रोसेस, राइट? सो by looking at this sample data, we make some assumptions like the distribution would be maybe a Gaussian distribution or maybe some other distribution, right? So here, based on this sample data, we have the assumptions about the underlying process, and we say that the sample data has been taken from, let's say, this Gaussian distribution, right? And what's the parameter of that distribution? That is unknown to us, Alright, now let me talk about that where this probability and statistics play a role into this machine learning. So the probability, so let's suppose you have this known parameters of the distribution. Let's take the Gaussian distribution. So you have this non parameter, that is the mean and the variance, right? So and let's suppose that you have this data that so you have this data, or you can say you have this observation, right? So the probability works in forward direction. If I know the distribution and its parameter, I can compute the probability on seeing certain data, right? If I let's suppose if I know that the if I know that salary follows a Gaussian with mean mu and the variance sigma, right? So I have known to it that the salaries of the persons follows the Gaussian, and it has the mean, that is mu, and sigma, that variance is sigma. So these two parameters known to me, right? Then I can compute the things, that what is the probability that the new customer earns between 40,000 to 50,000, right? So the probability works if you have the known distribution with known parameter, then you apply the probability to the observation or the data, and you ask or you find the probability of the event, or the conditional probability, or the joint probability, or the marginal probability, right? And the statistics works in reverse direction, right? Here I don't know the distribution or its parameter, that what is the distribution and what is the parameter, that is mu or sigma. We don't have the idea about that. What we have is the sample data, right? So I have only the sample data, and from the data what I do, I try to estimate the parameters of unknown distribution, right? So this is what the statistics is. So if you have the known distribution and you know the parameters of the distribution, right, you apply the probability to answer questions like what will be the probability that the customer earns between 40,000 to 50,000, these kind of question. So you can apply everything that you have learned so far in the probability. If you know the distribution, you can find the marginal distribution, you can find the conditional distribution, all these things, right? And let's suppose you have the sample data from some underlying distribution, and that distribution is unknown to us. So what you do from the sample data, you try to find, or you try to estimate the parameters of the distribution, and that is what you do in the statistics, right? And the machine learning builds right on top of that. Machine learning takes the data, uses statistical method to estimate parameter, and then uses the probability again to make the prediction about new data, right? So we have this data. Let's suppose we have this data, and let me introduce one more terminology here, that is the training data. training data. So if you take this example, so the bank have the records that the first person have got the are eligible for the credit card. So this is the person profile, and if he is eligible to get the credit card or not. So bank have this information from the past, right, and they have done it, let's suppose manually, everything, right. So and x2 is the person that is not eligible, and x3 have the profiles person and that is eligible, and so on. We have such n person, and let's suppose that another person is not eligible for the credit card. So this is what we refer as a training data. And why we are referring it as a training data, you will see as we go on, right, because we will be using these data to make the models or train the models, right. So that is why we are calling it as a training data. And this data in machine learning is have the very important role, right. And as we go on we will see, right. So right now just you need to understand that what is the training data, right. So you have this training data, so let's call these xi, and the eligibility, let's denote it as a binary variable, right. So this y, that is the person, if the person is eligible for the credit card or not. So it might be eligible for the credit card or it might not be. So this y can only take two values, that is 0 or 1, depending upon the profile of the person, right. And we have this information with us, so we have this data, right. What we do using this data, what we do is we uses some statistical methods to estimate the parameter. टू एस्टिमेट द पैरामीटर्स, राइट. अब देखो, जैसे कि अगर हम एज्यूम कर रहे हैं कि this all these data has been sampled from some Gaussian distribution, right. So अगर ये Gaussian distribution से sampled हुए हैं, तो depending upon the mu and sigma we can have infinite number of such Gaussian distribution, right. अब उसमें से कौन सा जो है परफेक्टली डाटा को फिट करेगा, right, that will again depend upon that what's the mu and the sigma, that is the mean and the variance of that distribution is, right. So what we are going to do, we are going to use some statistical tools, right, to estimate the parameters, that is the mu and sigma, right. And there are many way to estimate given the data, right. What is more interesting to us in this course is the maximum likelihood estimation. In short we write is that MLE, right. So it is one of the tool, right, one of the statistical tool, right, that estimates the parameter, right. And we will be looking at this maximum likelihood estimation, right. Now if you observe here, so we have a set of hypotheses here. Again I am introducing a new term, and this hypothesis is not a new term, you must have already if you have already gone through the statistics of probability and statistics course, you must have the idea that is what is hypothesis. So if the underlying, if we are having the assumption that the underlying distribution is Gaussian distributed or the normally distributed, then depending upon these parameters, we might have a set of distributions, right? We might have this distribution, or we might have this distribution, right? Or we might have this distribution, right? So if you look at all the mu and the sigma are different to different distribution, right? Here the shape is narrower, so the variance would be different than all these distribution, right? So here we have a, if we are assuming that the data that we are sampling from some Gaussian distribution, then we might have a set of hypotheses that data might be more likely that it might came from this distribution than this distribution, right? So this is the set of hypotheses, right? And what we do, we are going to use one of the method from the statistics that we call is the maximum likelihood estimation, right? And what it will do, so we apply this maximum likelihood estimation and we pick or we estimate this mu or sigma, and that we are going to refer as our model. So one more terminology here, the model. So model for this particular example is nothing but, so what we have done, we have the set of hypotheses, right? The distribution could be this one, or maybe this one, or maybe this one, any of it. So we have infinite number of possibilities in this set, right? And through this tool, through this statistical tool, using this maximum likelihood estimation, we are picking the, or we are estimating which one is the most probable distribution, or which distribution will fit or will have the more likely than other distribution, which distribution is more likely than the other distribution, right? So if our most of the data falls here, right, then obviously this distribution will be more likely than this distribution or this distribution, right? So this maximum likelihood estimation, you are using it as a learning tool to see that which distribution is more likely than other distribution, right? And that distribution you are going to call from this set of hypotheses, that you are going to call it as a model, right? And once you have this model, what you are going to do, you are going to feed this new model a new data point or a new data. So again, a new profile, someone has recently opened a bank account, so it will have the profile and it will again have the D features, right? And you're going to feed this to the model, and this model is going to predict if the person should get the credit card or not, right? And how you are going to do that? Again, you are going to have the, and you are going to apply the probability so you are going to use the probability to predict the output. And what is output here? That if person should get the credit card or not. right? And so what we are trying to do, so here we have some ideal function, let's call that function f. So this is ideal function that that we don't know, right? And here we give our input, and it tells you that if the person should get the credit card or not, right? So this is our ideal function, right? And we can never achieve this ideal function. Here what we are trying to do is, through our learning process, we are having this model, and this model will approximate our ideal function, right? And how good or how bad is our model, that will again depend upon that what is the outcome that we are getting it, right? But the main idea behind is that this model approximate this ideal model, this ideal function. Alright, I think you have got a few idea about the machine learning and how it is coupled with the probability statistics and the linear algebra. And this function, that ideal function that I am referring, what we so this has a terminology that we call it as a target function that we want to achieve, right? And in practical, this is not feasible to exactly achieve this function, so we try to approximate this function, right? So this is the target function and this is the model. So this model is nothing but the approximation of this target function, right? And this process, what we refer as a learning process. So this what we refer as a learning process, right? And this is your set of hypotheses, right? And from this set of hypotheses, this learning process picks up the most likely distribution for this particular example, and that approximate our target function, right? And once we have this model that approximate our target function, so we give the input or a new input to this model, and using the probability we make the decision that if the person should get the credit card or not, right? So this is just to give you idea that how probability statistics play role into this machine learning course as well as this linear algebra, right? So in next lecture I will give you the template that what is maximum likelihood estimation and how to find it, right? And we will go through just few examples just to have a good grip on maximum likelihood estimation, right? And afterwards we will be looking at the core of this subject, that is on the machine learning, right? And you must have got the sense that we have already started. Alright, so that is all in this video. In next video we will look at maximum likelihood estimation. Thank you so much. And if you want to do the more practice problem, just enroll into this course. And if you are watching this lecture, then you must be already enrolled into this course, and I have already put the practice problems for the machine learning, and as we go on with the course I will be putting more and more problems, right? And all the problems in the practice problems section or in the quiz section will be completely based on what we are doing in the lecture. Thank you so much.